Can you hear me, Sarah? Okay, good. Um, Tell me if you can hear these sounds. So this is crickets. All right, welcome everyone. My name is Karim Ali. This is going to be the first lecture for Compute 416 for undergrads and Compute 500 for grad students. Please let me know if you're attending this class as a UAlberta student. Please let me know through the Zoom link, whether chat or just unmute yourself and tell me whether you can hear me or not. If you are on the live stream, just tell me on the Twitch live stream chat whether you can hear me well or not. Okay, the voice is not clear. I'll be working on that to improve it for the upcoming lectures, so please bear with me while we're all getting used to this extraordinary setup. All right, so let me just quickly start this lecture today. So just so you know, this is the Foundations of Program Analysis course, 416 or Compute 500. Like I said, my name is Karim Ali. It's a pleasure to be with you here today, even though we can't be physically on campus, but it's a pleasure to be with you either online or through the Zoom link if you're a UAlberta student. Just a little bit about myself. So I have done my bachelor's degree in Egypt at the American University in Cairo, graduated in 2007 with a bachelor's degree in computer science, and I worked for about 6 or 7 months in industry in Egypt before I moved to Canada in the end of 2007 at the University of Waterloo, where I did my master's and PhD. So for my master's degree, I did my master's in network security, and then I took a course while doing my master's in programming languages, where I found myself to be more interested in that topic. So I decided when I wanted to do my PhD to pursue my grad school studies in programming languages instead. I graduated from the University of Waterloo in 2014 with my PhD degree. And shortly after that, I moved again across the Atlantic to do my postdoc in Germany, where I worked with Eric Boden and his group, where I actually got to apply my expertise both in static analysis or program analysis, which is the main topic of this course, but in addition to security, which was my expertise from my master's, in developing various static analysis techniques for security purposes. So trying to detect security vulnerabilities in applications and figuring out how we can improve the security of applications. Then, since 2017, I moved back again across the Atlantic in the reverse direction, where I joined the University of Alberta, and I have been an assistant professor there since 2017. Working primarily as the director of the Maple Lab, which is the name of my group, where we do research related to programming languages, and more specifically in program analysis, where we research techniques on how we can make program analysis more scalable, more precise, more usable by various users or software developers, to be more specific, spanning various degrees spanning various topics like just-in-time compilers, security-related analyses, symbolic execution, and so on and so forth. So that's a little bit about myself. For whether you're attending the live stream on Twitch or the Zoom chat, just tell me a little bit about yourself so that we can all get to know each other a little bit more. So if you are in Zoom, you can unmute yourself and just say who you are, which program you are part of, and what do you expect to get out of this course. I'm sure everyone has a different order of people, so just feel free to unmute yourself and just tell me a little bit about yourself. If you are on the Twitch live stream, you can just write it in the chat if you prefer that instead. Thanks, Henry. Um my guess, I guess next would be anyone else, or should I start going through the list of attendees? Cool. Anyone else? Hey. Cool. Thanks, Akalanka. All right, so here's how I'm going to do it. If I ask you to unmute, then it's your turn to say a few things about yourself. By the way, just to let you know, the Zoom call is not going to be part of the live stream. So whatever you say in the Zoom call stays between you as a UL Alberta student and myself. The live stream is only showing me and my iPad where I'm showing the lecture or whatever I'm writing and sharing with you. So it's still as close as possible to a classroom setting as I can make while being remote. So if I ask you to unmute, so please, it will be your turn to say a few things about yourself. Mm-hmm. Cool. Thanks, Tribe. So again, for those who are joining us now on Zoom, if I do ask you to unmute, that means it's your turn to tell us a little bit about yourself, which program you're in, and what do you expect to get out of this course, or what made you interested to join the course. Hey, Jackie. All right. Thanks, Jackie. Hey. Cool, welcome aboard. All right. Yeah, glad that everyone was able to make it. I know that not many students in the class were able to make it because E-class is down. Unfortunately, I don't seem to find a quick, easy way to reach out to everyone in the class to be able to share with them the Zoom meeting, and I cannot share the Zoom meeting password on the Twitch stream for sure. So I'll figure out something else for the next lecture so that to see. Hopefully, E-class will be up by then, but I'll figure something else. I hope that if you're joining through Zoom, that the audio. Oh, we have more people joining now. But anyways, I hope that the audio quality is now better. I changed the mics that I'm using, so hopefully this is going to be better than before. And if you just joined right now, I'm going to ask you to unmute. So tell us a little bit about yourself, which program you're in, and what made you join us today or take the course. Cool. Yeah, we'll get to know that today. In fact, in less than a minute, we'll be able to do so. So welcome again, everyone. So now that you have known a little bit about myself and I've known a little bit about yourselves, let's dive into it then. So, cost of software bugs. So, how much do you think, or can you estimate how much software bugs cost every year? Just a ballpark figure. So that cost would include the cost paying developers to fix those bugs and testing and deployment of the software after fixing and so on and so forth. How much do you think it costs per year? Somebody is saying in the order of billions. Can you be more specific? And I strongly encourage you, unless your mic is not properly working, if you are on Zoom, I'd prefer if you just talk in the mic rather than sending on the chat. So we have in the order of billions. Anyone else wants to take another guess? So indeed, it is in the order of billions, thousands of them actually. So in fact, the cost of software bugs or handling software bugs between the year 2008 and 2013 is about $1.6 trillion during that period of time. So just to give you an idea how big that amount is, if you don't know already, the Eurozone bailout to bail out countries that went into economic recession during the same period of time in Europe, in the European Union or the Eurozone, was about $600 billion. So we're talking about almost 3 times the amount of money needed for the Eurozone bailout just to handle software bugs during the same period of time. So it's kind of a big deal, software bugs and how much they cost. So here's an example of a bug that you may see. Here's an example of a bug that you may see out there. I'll just give you a minute or a couple of minutes or so to look at the code. Tell me if you see anything wrong with it, and if so, what is it and what does it do exactly? And you're welcome to ask me questions on the Zoom channel as well, or if you want to ask me on the live stream chat also that's also fine. So this is C++ like code in a very famous system that many of you probably have used before. There is a duplicate code. Where is it? Okay. There is, yeah, okay. Okay. Really good. There is a duplicate go to fail there, right? You see there where the red arrow is? This is where the duplicate go to fail. So some developer who is writing this code probably will just copy pasting code from one place to the other, and they just duplicated that go to fail by mistake. That go to fail causes the following. That second go to basically will always be executed because it's not really part of the if statement, because it's not like C or C++ doesn't work like Python with indentation. You have to include parentheses to properly include a block of code into the body of the if statement. So that second go to fail will always be executed, which means that the code will skip that verification step where the code is verifying the validity of the SSL certificate that is being passed along to that method, which means that it will pass that verification, it will go directly to the fail block, and then it will continue working as expected, and will just return an error code to the caller, but it will execute the program properly. So it means that it will bypass verification, so that code allows invalid SSL certificates to be used by that piece of software. So if you don't know what that piece of software is, it's actually part of the iOS, it was part of the iOS code base. So this bug is infamously known as the Apple go to fail bug that was in iPhones and iPads and all iOS devices before the year 2014, I believe. Until Apple got it fixed, for which it won actually the Pony Award for that year for the most ridiculous bug or software vulnerability or security vulnerability that you can have in your system. So this is an award that no company would like to win, or no entity or system would like to win ever. But unfortunately, that was the case for this specific bug here. There are other bugs as well that are more serious, like bugs that are in the ABS braking system for Toyota cars that cost about $3 billion US by the year 2009, I believe, and unfortunately also led to people losing their lives or other accidents as well due to that lag bug due to a concurrency bug in the Toyota braking system. There were also a few other vulnerabilities in medical implants by a famous company called Medtronic, where basically a medical implant is something like an insulin pump or a heart regulator or something like that, and the security vulnerability in those devices, and that was found as recent as March last year by the Department of Homeland Security in the US, and that basically allowed a remote attacker to gain control of that medical implant and remotely control it. So if you think about a heart regulator or something like that, or a heart medical implant, you can basically send a jolt remotely to that implant, killing somebody. So it's kind of a remote kill switch. And that was part of the security vulnerabilities discovered in those devices. So what I want to talk to you about today and also in the future lectures in this course is that all these bugs and more, we are actually able, or we could detect those bugs and possibly even fix them using a technique called program analysis. So what is really program analysis? Anybody heard about program analysis before? Would like to take a guess what program analysis is? All right. So program analysis is just a way of understanding the runtime behavior or reasoning about the runtime behavior of programs without necessarily having to execute it. So you have a program, you don't have either the luxury to run all possible executions of a program, or you just want to know what the program will do without running it. Maybe it has some vulnerabilities, so you don't want to run it so that you don't expose your system to those vulnerabilities. So this is what program analysis is, and more specifically, static analysis as well. So program analysis has been historically used in various different fields in computer science. So it has been used famously in compiler optimizations, such as parallelizing code. So you have a code that runs sequentially, and you want to make use of the recent advances in computer architecture and run it in parallel on multiple cores or multiple devices or servers. So compilers can do that for you. Constant propagation, which reduces or eliminates computation of expressions. Static inlining, so that improves the runtime performance of your programs, because then you wouldn't need the program wouldn't incur the overhead of calling methods. Date code elimination, it's used quite a bit in mobile app development, because there you have a limited space on the mobile devices, so you want to make sure that your app only ships and deploys with the code that would actually be possible to run or potentially could run on the device, and not everything that you have in your code base. In addition to that, program analysis is used quite a bit, even without you knowing, in integrated development environments. So if you have used anything like Eclipse, IntelliJ, VS Code, Xcode, any other development environment, and you have used something like code navigation to figure out where are the references of a certain field or a method or a class, or the uses of a certain method, or to refactor a piece of code, like extracting a piece of code from a method into a separate method or an external method, or in code recommender systems. So if you're using your IDE and you type in or you press Control or Command if you're on macOS and space, and it shows you a list of all the methods that you could possibly call, this is actually running a program analysis in the background to figure out, given the context that you're in right now, which is your edit point, what are the possible or potential methods that could be called at that point. Program analysis is also used in making sure that certain critical systems adhere to certain standards. So that's used quite often in automotive industry, in hospitals like MRI machines, making sure that they emit the right amount of radiation for patients, and also for airplanes and the aviation industry in general. Like you don't wanna fly a space shuttle into space before you know exactly that the software that is going to run it will actually do what you expect it to do. Otherwise, you don't have the luxury to try out a few space shuttles every now and then until you get your software right. So you have to make sure before it goes up in space that it will work properly. More importantly, program analysis is used quite often in the field of security. So there is a ton of tools out there that detect security vulnerabilities in applications, whether those security vulnerabilities are just simple issues in your program, or severe issues like accepting invalid certificates, or encryption, or using improper encryption and decryption, and so on and so forth. So there are different ways and different fields in computer science where program analysis actually come in play and is used quite often there. And we're going to learn about all those techniques and all those uses and all those applications throughout the course through learning through the following topics. So some of the topics that we're going to discuss in the course is going to be some introductory topics and fundamentals about program analysis, like intermediate representations, for example. We're going to also talk about intra-procedure analysis, how you can perform an analysis within the boundaries of one method. We're going to talk about call graphs and how you can create relationships between methods or callers, so methods that are starting a call, and callee methods, or methods that are being called. We're going to learn about pointer analysis. If you have pointers in your program or references, what potentially those pointers could point to in memory at runtime without running the program. How can we deduce that? We're going to talk about some frameworks, important frameworks that we use in program analysis, like IFDS, and how IFDS covers a large class of analyses where you want to reason about data flow in the program. Where you want to reason about data flow in the program. We are also going to talk about usability of program analysis tools, where we want to know that it's not enough that you have a reasonable analysis or you have a fast analysis or a scalable analysis, but you also want to make sure that developers or users in general who eventually are going to use your tools are going to be able to use it in a way that doesn't break their normal workflow or the workflow of the normal day-to-day task. So to achieve that, we're going to do a mix of things in the course. So we're going to do the lectures that will cover the first half that I just talked about. And we're also going to have a few paper seminars and paper readings throughout the course. So paper seminars are going to cover a wide variety of topics, like developer support, Android security, distributed static analysis, dynamic languages and analyzing dynamic languages and other type systems, probabilistic programming, and machine learning related topics like how we can use program analysis to verify the validity of a neural network, for example, and so on and so forth. Program synthesis, which is a famous technique in program analysis and in compilers as well, where you want to generate code based on a certain criteria or a certain recipe that the developer writes down. So this is a wide variety of topics and a wide variety of topics for both the lectures and the seminars that we're going to go through in the lectures, in the class throughout the semester. So this course in general, the way we're going to run it is that it's going to be a mix of lectures and in-class hands-on experience. The first part of the course, or the first portion of the course, up until a week or so before reading week, is going to be mostly lectures by myself. There will be 1 or 2 lectures where we're going to have hands-on experience with static analysis tools. There will be 1 assignment where you will get a chance to work with static analysis tools even before knowing anything about static analysis, because the assignment won't need any prior knowledge about static analysis, just to get you started with that course. We're going to have a few assignments throughout the semester, spread out every other week almost. We're going to have the paper seminars in the second half of the semester, and then we're going to have the big bulk of the grade is going to be for the course project. Almost 45%, or exactly 45% of the grade is going to be on the course project. At this point, I'm supposed to actually show you the eClass page. However, as most of you know by now, that eClass is down today on the first day of lectures. But luckily, I do have eClass available on my iPad screen. So I'm just hopefully going to be able to maybe refresh the page. Is it still undergoing maintenance? Yes, it is. I was going to show you actually the course outline where we have the layout of the grades. eClass is working again. Well, I hope you're right, because it's not working for me, unfortunately. But anyways, at least the home page is working properly, so I'm just going to depend on that. So if you go to the eClass page when it's back on, you will see that we have news and updates forum. So this is going to be the main communication means between you and I. Anything that is related to the course, announcements about upcoming assignments, grades uploaded, anything related to the course, I'm going to announce it through there. That's going to be the main ways of communication between you and I. The second link there is going to be the eClass forum. So this is a public forum, which is going to be the main way for you, that I strongly encourage you all to use in order to communicate with each other. So let's say somebody wants to ask a question I strongly encourage you to post that question to the forum before you ask directly either myself or Ifaz, who's going to be our TA, where I'm going to get to that soon. Just post it there. If you have a question, there's probably at least 2 or 3 other students in the class who have the same questions. Just post it there. It's going to be faster for me and Ifaz to get to you right away rather than emailing each one of us privately. So keep private emails just for things that should be private, like if you want to discuss like your grade, for example, or you have a private or personal issue that you want to bring up with me or Ifaz, our TA, that is related to the course. The next link was going to be the course outline, and I'm hoping that it is going to be okay. So now it's asking me to log in again. Let's see if that works. That seems to work actually. So great. So now we can actually go through the course outline together. So in the course outline, you'll see an overview of the course, the objectives of the course, a few prerequisites run for the topics that I just discussed briefly on the slides, and then the coursework and evaluation. So this is really important. So this class is mixed between grads and undergrads. There are 3 main components for evaluation in the course. There are assignments, there's 7 of them, and there are seminars. You only need to do 2 of them, and I'll get to each one of them soon. And then there is a course project. I am marking there for the assignments, the seminars, and whether you're grad or undergrad, whether each component is going to be done individually or done in groups. So grad students, so for assignments, everybody in the class will do them individually. For the seminars, everybody in the class will do them in groups. For the course project, grads are going to do it individually to separate them from the undergrads, because the expectation will be higher from grad students for the course. For undergrads, they can do it in groups. And I'll also get to how the groups are going to be formed and so on. The weight for the assignments is 35. There are 7 assignments. We're going to drop the lowest grade out of those 7 by the end of the semester. Seminars, there's 2 of them that each one of you will have to do in groups, of course. Well, 2 each group will have to do, so you cannot change groups for the seminars. For the course project, I divided the course project deliverables as much as I can so you can have more feedback, milestones, and points as we go. So there is a proposal presentation and a document, a final presentation and a document, and then there is the GitHub repository that is related to the code that you will submit as part of your project. And I'm going to get to the deadlines and so on. Assigning the final letter grade, you have to get at least 51% in the course to pass. To remain fair to all the students, there will be no curves, no curves or adjustments to the grade. These are the cutoffs for all the grades that is now part of the outline, which means I cannot change them at any point whatsoever. Just to let you know, all these grades, all these cutoffs for the grades are at least 3% less than the historical distribution of the grades that I have seen in the course in the last 3 times that I've taught it at the U of A and a couple of times that I've taught it elsewhere. So I think this was reasonable enough to set. Excuse me. So for this course, we are not following any particular textbook, but just to make it easier for you, I listed a few of them there in no particular order. So if you want to check them out, some of them are in the library, and I added the library catalog there, entry for them. Some of them are not, unfortunately, but if you need access to them, to the ones that are not in the library, just let me know and I'll figure out a way for you to do so. The other thing that we should note is that this course will abide by all the course policies that the Department of Computing Science follows, but there is also an additional set of policies that I would like to share with you right now. And I strongly encourage you all to go through those policies line by line in your spare time to figure out, to read them exactly and how they may affect our interaction throughout the course, given this extraordinary measures that we're in right now. The first part is about excused absences and reevaluation. I really want you to read those on your own time. Online course delivery. This is part now of our course policy now that we are delivering everything remotely online. So there are rules that will guard the course community, whether on the live chat, on the live stream on Twitch or the Zoom meeting that we're going to have, how we're going to deal with each other. You have to abide by all these rules, otherwise it's going to be a violation of the Code of Student Behavior. Presentation. Now that you're going to be presenting a few presentations in the class and participating in the class, there are certain things that you should consider if you're going to use your camera or use your microphone. So please follow these considerations. And then one important factor is privacy and confidentiality. It goes without saying that you cannot just record the meeting on your own without taking permission. It's going to be a violation of the course policy. You cannot share any person's image or comments or information without permission. You cannot share any materials that we discuss in this class externally. As I mentioned before, the Zoom link that I'm sharing with you is private only to the U of A students enrolled in this class. You should not share that with anyone outside the class, otherwise it will be a violation of the Code of Student Behavior. The Twitch live stream is just there. Anyone can join it, but the Zoom link and the Zoom meeting is only private to the U of A students, and it's not going to be part of the recorded live stream, which I will make available to you guys later on. Then there is going to be conditions of use and lab policies. Doesn't necessarily apply to us right now. Academic integrity, collaborations, and so on. I really want you to read those on your own time. One important thing that I should say or note that I should bring up regarding being on campus for this course. You do not need to be on campus for this course whatsoever. You must not be in campus for this course whatsoever. Whether for the lab, there are no labs for this course, first of all. And you don't need to be on campus, whether in CSC or Athabasca or whatever it is. You should not be on campus for this course. You must not be on campus for this course. I cannot stress this enough. I wish you all to be safe and sound. So please, let's help each other out in maintaining that. The other link that is important that I'm just going to briefly share with you is going to be the course schedule. So the thing that I'm showing you now is I have a distribution of, or I have a layout for all the lectures, the plan for all the lectures from day one to the last day of the classes. So there you're going to see all the topics. Each topic, once we are done with it in class, I'm going to change that topic to have the direct link to the YouTube recording of that lecture from the live stream, so you can follow it later on. Anything, and you will have the legend up here above the table to tell you what each color means. Anything that's in pink, that means it's a course deliverable that you have to submit. You will see the deadlines for all 7 assignments there in that course schedule. They are all going to be on Friday. Anything that is due is going to be due by 5 p.m. on the day where it's of the deadline, just to make sure that Ifaz and myself are going to be available to you until the last moment of the working day of that deadline. So I'm not going to ask you to submit something by midnight or by 9 a.m. on Monday or something like that. It's unreasonable to ask you to do that, something like that, and I'll never ask you to do something like that. So please go throughout the plan of the course. Make sure you plan ahead. You have everything that is due for the course laid out on this. It is not going to change. The only thing that may change is the time for the guest lecture, which I'm planning ahead with a very interesting guest lecturer that will join us for this class for one of the classes. But you will see there where the proposal presentations are due, the proposal document, the paper seminars, the final presentation, the final report, and all the assignments. I'm going to stop here for a few seconds, just if you have any questions on the Zoom meeting, if you want to ask any question about what I discussed so far. It can be on any topic that is related to program analysis whatsoever. And I'm going to get to that when I talk about the course project in a few minutes. Any other question? All right. So following that, the contact information is here. This is my name. This is my email address. Office hours. My office hours are going to be by appointment, and we're going to work it out whenever needed to accommodate your schedules. I put in the information for Ifaz Kabir, who's going to be our TA. He's a PhD student in our program, and he's a fantastic TA for this course. He has taken this course a couple of years ago, or maybe a year and a half ago, and this is his second time taking the course, so he knows it inside out. So he has his TA office hours there, and the Google Meet link there, and he can also meet you by appointment. And all that information is in eClass, of course. I have made available to you a few resources. So if you click on that first link here, you will see a bunch of books and links and papers that are related to the topic. So you're welcome to get started on reading some of that literature and just ask me any questions if you have any. I also have a link that will show you the source code that I'm going to use for one of the hands-on lectures that we're going to have in the class later on about call graphs. There is a link here about potential project ideas that will come or may come in handy if you wanna think about some ideas related to the project. So it's only bullet point one-liner ideas, so nothing really in detail there. If you're interested in any of these topics, just let me know, and I'm happy to talk to you more about it. But you're definitely encouraged to pick whatever topic you want for your course project. It can be anything you want to work on, as long as it's related to program analysis. If you're doing any kind of research, whether you're a grad or undergrad student, I even strongly encourage you to make sure that the project that you're going to select is somehow related to your research, if you want it to be. I'm fine with that. I'm not going to be picky about the exact topic that you want to pick for your course. One thing that I would like to ask of you to fill out today is that entrance survey. So the entrance survey is something that I usually do I actually started doing that last semester, just to ask all incoming students a few questions about the course, just for my own benefit, so that I can assess a few things at the end of the semester and then use that information to improve the course further in the future. So please fill out that entrance survey. I'll keep it open for a week or so to accommodate people who are dropping and adding courses at that time. It's going to take like a minute or so of your time to fill it out, but it's going to help me a lot when I assess how the course went at the end of the semester. I'm going to have all the links that are related to the course online delivery here. So you see a link to the lecture Zoom, you'll see a link to the Twitch live stream, and there is a link also to the lecture recordings on YouTube. Like I said, the Zoom link is private. You should not share it with anyone outside the class. Twitch is going to be public, and YouTube is going to be unlisted, which means I'm still debating whether it should be unlisted or public, depending on how much class private information is going to be there, but we'll assess that as we go throughout the semester. For the assignments, as you can see, all the assignments are there. You can go and read every single assignment as we go. There are 7 assignments, like I said. We're going to drop the lowest grade in all of them, all 7 assignments at the end. Forget about assignments 0.0 and 0.1 for now. I'll get to them later. And you also have the rubric of each assignment right there. So you know exactly how each assignment is going to be graded. You know exactly what things that we're going to be looking for. So everything is clear and transparent from day one in this course. Having 7 assignments might be a bit too many assignments, but in fact each assignment is roughly 1 question. So you know exactly how each assignment is going to be graded. You know exactly what things that we're going to be looking for. So everything is clear and transparent from day one in this course. Having 7 assignments might be a bit too many assignments, but in fact each assignment is roughly 1 question. I mean, not a small question, but we basically split up. In this course, we used to have only 3 assignments before, but they were considerably large assignments, and they will take a month or so to solve. With consultation with IFAZ, we decided to split the assignments into smaller chunks so that you can have more milestones of evaluation as we go throughout the semester. And I think this is going to be even more important in a remote setting like that, so that there's more interaction between yourselves and myself and IFAZ as well throughout the semester, and you get more feedback as you go, rather than having feedback only at a few points along the way. So the next item in this course is going to be the seminars. So for the seminars, we're doing something a bit different in this course. If you have taken any of my graduate courses or other courses, basically my grad course, you'll pretty much know how the seminars will go. But if you haven't, usually what happens in seminars at courses is that papers are assigned to people. One person presents a paper and everyone else sits down and listens, maybe plays on their phone or checks their email in the back row, or sleeps in the class, or doesn't even care about what the paper is about and doesn't read it, and so on and so forth. So to make it a little bit more interesting, we're going to have different roles for people participating in these paper seminars. So we're going to have a presenter role and a validator role. And if you open each one of them, it will tell you exactly what are you expected to do in this role. So if you're a presenter, and it's going to be done in groups, so you're going to read the paper, your group is going to read the paper, and then you're going to give a conference-style presentation about the paper. So you have, forget about the 14 minutes or so now, that needs to be adjusted, but I just didn't have access to eClass over the last few hours to do so. You will get a chunk of time, about 20 minutes, to give a conference-style presentation about the paper. So start looking for conference talks online, and now there is plenty of them given the current remote delivery of all the content in conferences, and see how people present papers at conferences. So you'll give one of those presentations. For the validator, they will do something a little bit different. So they will still have 20 minutes also, or maybe even more. We'll see how that will go. But their task is going to be quite different. Your task is not going to be to present the paper, but your task is going to be to present the artifact that comes with the paper. So what does an artifact mean? An artifact means maybe the paper comes with some code, so show us how to use that code. Maybe it comes with some tool, show us how to use that tool. Maybe it comes with a data set, show us what the data set is about, how we can use it, how we can reproduce the results in the paper, maybe how we can replicate the experiments in the paper. Maybe the paper comes with a proof. How does the proof work? Is there an easy way to navigate through the proof in the paper, or is it just a dry theoretical proof that only a handful of people in the world can understand what it is doing? So your role is going to be to validate any artifact that comes with the paper and present that in class. So that's for the seminars. For the course project, like I said, there are 3 components. There is the proposal, there is the document, there is the proposal presentation and document, there is the final presentation and document, and then there is the GitHub repository. So if I go back to the course schedule, you will see that I put in the deadline for the proposal document, which is right there in that highlighted cell. This deadline is intentionally before you do your presentation. This is for a couple of reasons. First is it will encourage you to work on your presentation early on, and it will also encourage you to think about what actually goes into your proposal and before you get to present it. Then we're going to see, you're going to have the paper seminars, and then we're going to have the final presentations on the last day of classes, and then the final report is going to be due on Friday after you're done with your presentations, just to give you a couple more days. Excuse me, a couple more days to work on any final polishing that you want to do to your project after you're done with your presentations. The slots for the final presentations and the proposal presentations are going to be randomly, so you don't get to choose your slot, but you do get to choose your project partner. So that takes care of that. For each one of the presentations, so let's say the proposal presentation, for example, you're gonna see there exactly how long the presentation is going to be. So the proposal is going to be 5 minutes only, so it's a very short presentation. 3 minutes speaker time, 1 minute question and answer, 1 minute transition, and you'll also see the rubric that I'm going to use to evaluate your presentation. So there is a big difference between how I'm going to evaluate the presentation and how I'm going to evaluate the document, and that applies to both the proposal and the final report as well. But you will see all the information there, and feel free to ask me any questions if you have any questions about that rubric and how it works. You'll see the same thing for the proposal document. It's right there. You'll see what am I expecting, how long I am expecting the proposal document to be, and what again is going to be my rubric to grade the proposal document. The same thing I'm doing for the final presentation and for the final document. So the final presentation is going to be a bit longer because we have more time and you're going to present more results. But again, you're going to see the rubric there. The same thing for the document. For the final report for the course, there are a lot more details regarding what goes into the document, because it's going to be treated as if it's a conference paper. And there is a lot more details about the rubric and what am I expecting to see in that document. And I strongly encourage you to go through that rubric as well. The last thing that I'm going to show you about the course project is the GitHub repository and what I expect this GitHub repository to include, or how it's going to be even graded. There's a few marks there, and there's the rubric that I'm going to be looking for when I'm grading your GitHub repository. So something like, do you have a reasonable README file that helps me navigate through your code? Do you have instructions to replicate or reproduce the results? So hence, you get to exercise your validator role that you have done in the paper seminars on your own code repositories for the project. Data availability, result replication and reproduction, and so on and so forth. That's pretty much most of the things that I wanted to share with you today regarding the course. I don't think... oh yeah, one more important thing. I mentioned that for the in the course schedule, sorry, in the not the course schedule, in the course outline. So in the course outline, I mentioned that assignments are going to be individual, so that's pretty clear. Seminars are going to be groups. So how do we select the groups? Well, this is where assignment 0.0 and 0.1 come in play. So assignment 0.1 is choose your partner for the seminars. Partner or partners. So I think a good number is maybe 2 to 3 at most for partners in the course, in the paper seminars. So if you want to choose a partner for the seminar, you get to do that. You have a deadline by October 6th. You should choose your seminar partner. And why October 6th? Because that will give me a couple of weeks to prepare the schedule for the paper seminars that you're going to have. You are not going to get to choose which paper you want to read though. So you get to choose your partner, so you can work with whomever you prefer to work with. But again, the papers are going to be randomly assigned to these to the groups that are going to participate in the paper seminars. The next thing that you need to do as well by September 29th is going to be related to the course project. So if you are a grad student, well, good news, you don't have to worry about that because you're going to do this work individually. If you are an undergrad student, you need to choose your project partner. For the projects, you can choose whomever you want to work with, and you can choose whichever project you want to work on. There are no limitations there whatsoever. And you need to do that by September 29th. September 29th, so that's almost a month from today. That gives you plenty of time to figure out who you want to work with in the class. If you don't have a partner, I encourage you to send an email on eClass on the forum and ask if somebody else is maybe looking for project partners, so you can partner up with them. If you can talk to people, you can email people, you can chat with them if you want. I encourage you to do that. And the other thing that I encourage you to do is, from the time that project partners are going to be decided up to the point where the proposal document is due, it's about 2 weeks or so. During that time, once the course project partners or course project groups are going to be formed, you should be talking to me about what your project is before you submit your proposal. So if you want to, just to make sure that your scope for the project and what you have in mind for the project is going to be feasible within the time limit that we're going to have in the course, and it's not going to be overwhelming for you for the course, and it is going to be relevant to the topic of program analysis, which is our topic in the course. So assignment 0.0 is going to be related to selecting your project partner. Assignment 0.1 is going to be related to selecting your paper seminar partner. I think that's pretty much it for today. That's all I wanted to share with you, folks. Do you have any questions for me? About the course outline, about the course in general, about how things are going to go? Any comments or feedback? I really, really appreciate any feedback that you may have about how the online delivery of the course is going. It helped me a lot last semester when I was live streaming and recording my 229 lectures even before COVID happened and so on. And that really made a lot of improvements in the course and how it was delivered based on the feedback from the students. But anyways, I'm going to stop talking right now. I'm going to wait for your questions or any comments that you have. Sure. Right. I just noticed that while you're speaking right now. So what do you suggest? Do you want also to have the same setup that I have on Twitch to be on Zoom as well? Okay. Okay. I will actually look into basically having the same setup that you're seeing on Twitch to be the same thing that you see on Zoom, so that if you want to use Zoom, you don't have to even log into Twitch or open the link on Twitch. If you want to use Twitch, you don't need to be on Zoom, so it will be up to you. But I'll try this out before our next lecture, and hopefully I'll get it working before then. No problem. Any other question or comment? Okay, so we have a question. Do students typically find this course to have a greater workload than other courses, or is it about the same as other 400, 500 level courses? That's a good question, but unfortunately I cannot answer that myself. I would recommend that you maybe ask students who have taken this course before, maybe ask on Reddit or something, but I'll tell you, for example, that if you're worried about the course load, if you're worried about the grade in the course, to be more specific, you shouldn't. If you do the work and I see that you're putting in the effort, you're going to do just fine in the course. So what I want from you is to enjoy your experience throughout the course without worrying about the grade so much. The course load is pretty much around the same as you would see in other 400 or 500 level courses. It is not any more or any less. It's right there in the middle. You have 45% of the course as your course project, which you can start thinking about a few weeks into the semester. You can already start forming groups right now and start exploring maybe topics that you're interested in, and then maybe talking to me regarding about how we can pick maybe some ideas that are related to that topic, that are related also to program analysis. The thing that might be a bit different is that the type of deliverables and the type of assignments in the class are going to be different than maybe what you're used to before. So paper seminars, for example, if you're an undergrad student, depending on the courses that you have taken, you might not have read many papers before. But again, to make that as smooth experience as possible, you have already I'm also going to make available some resources that will help you and guide you on how you're going to read research papers and what to look for in research papers. But you have already, for the roles that you're assigned for those paper seminars, exactly what you should be doing. And I'm happy to talk to you about it. I'm happy to discuss with you that before you get to do it yourself. For the lectures, I don't know, if you have taken 474 before or 272, these are going to be related topics, very related topics to what we're going to discuss in the class. But I'm hoping that it's going to be interesting. It is very applicable research. It's very applicable topic, as you're going to see throughout the whole semester, and as you're going to see also from the papers, and as you're going to see from the guest lecturer that we're going to have. I hope that answers your question. Any other questions or comments or concerns? All right, I take it from the silence that at least people on Zoom don't have any comments or concerns. So if that's all, then I would like to thank you all for today. And I guess we'll see each other again remotely on Thursday.